Hi, everybody. I'm Mitch Quinn. I'm the director of AI and machine learning at XBy2. I lead the research and development for our patient flow platform that uses AI models to anticipate care transitions and then help teams to act earlier in response to them. I also lead all the clinical validation of each of the models to ensure that they're safe, effective, and relevant to all the teams using it. Today, I'll share a case study from a community emergency department where we worked with clinicians to turn early physician intuition of, I know this patient is going to be admitted, into a calibrated real-time signal the whole care team can use to improve patient flow. But before we dive in, let's address the elephant in the room. Let's call him AI hype cycle because he's everywhere right now. Hopefully going away in just a minute. So he's here for an obvious reason, right? There's a ton of excitement around AI in healthcare today. And some portion of it is justified. We've all seen a lot of incredibly fast advancements. We've all seen a lot of incredibly fast advancements of AI capabilities. I've been working in this field for about 20 years now, since before my hair turned gray. And I've had a front row seat to a lot of those advancements and even been lucky enough to contribute to a few of them. It's been a really exciting time, but there are some big hurdles to overcome before you can implement these things and translate that excitement and promise in the AI labs to real impact in real world scenarios. So a big reason for all this excitement is that AI is really great at finding patterns in very messy data and complex data, and it can use those patterns to anticipate future events. But hospitals are great at breaking those patterns, right? Variation in patient population, data quality, workflows, everything's different. It makes any one-size-fits-all model that's built and just sort of given away very unreliable, and they don't translate well in practice. As the saying goes, if you've seen one hospital, you've seen one hospital. And there's so much variation. These places are where edge cases go to reproduce, right? It's all edge cases all the way down. So while AI advancements grab these headlines and likely dominate your LinkedIn feeds and email inboxes and all that, we all know that AI models alone don't move patients, right? This is the systems, workflows, and people that make that difference. And the models that we build have to be done collaboratively and iteratively refined with the teams that use them in order to become a good addition or a welcome addition to those teams. We like to say it's not building things for people, it's building things with the people that use them. So that's an important philosophy that we like to follow here. So the problem we're trying to solve here is transforming this notion where seasoned ED physicians will often say something like, I knew this patient would be admitted as soon as I walked out of the exam room. And that's true. But then they express frustration at bottlenecks and barriers, and the hospital does the same, that slow down the ED workup being completed, discharging the patient, or placing them in a bed once that workup is completed. So our goal was to minimize those speed bumps by transforming this intuition of laying first eyes on the patient, and minimize those speed bumps by transforming it into a consistent operational signal that you can then share reliably with the rest of the providers and supporting staff, and use it to better choreograph their actions to improve patient flow. So there are a few challenges in this, right? So the first one was in turning this intuition into an always-on signal that's delivered 24/7 that can be shared everywhere. Comes down to a few questions, right? How consistent is this clinical intuition, this idea across all the physicians in the ED, right? Is it the same for all shifts and across all patients? This is where some of those commonly available manually triggered bed ahead buttons that you might find in your EHR fall short, right? Because this variation in clinical intuition across the physicians have the hospitalist or the bed board start, not disregarding those signals because they're not reliable enough. They know who pushed the button, and so they'll not listen to it. Another one is how confident is it really, right? In most studies, physicians are really great at anticipating that disposition at first sight, but this is when considered as a group on average. And we can't practically consult a group of physicians every minute to get consensus on disposition for every single patient. It just doesn't work that way. And then when is the right moment to let the rest of the hospital know, right? Even though the physicians may be certain of disposition when when they first leave the exam room, there's no actionable information yet in the workup to start the downstream workflows. So that was a big one. So our goal was not to replace this clinical judgment or even influence it, right? We weren't trying to get in the way of that. We wanted to build a system that could reflect this disposition intuition among the most senior and highest performing ED physicians in the hospital, right? And then calibrate it so we knew exactly how accurately it would reflect the true final disposition. We needed to minimize any false positives to eliminate rework or any sort of confusion, right? And then we needed to work with the people who responded to the early signal, right? So the clinical coordinators, throughput coordinators, and the hospitalists to find the right time to share it. And critically, and you've heard, this is no surprise, it had to be EHR native, 0 extra clicks, no additional logins, no additional screens. Seamless integration into their existing workflow was a must in order for this to be used. So with that in mind, we started building a model. We started building this deep learning model. And this is where I get really excited because this is what I spent my career doing. But then we had to see if the model would work, right? So we started by using the historical emergency department encounters from our partner hospital's EHR. And we trained a deep learning model which could begin anticipating this patient's disposition from the moment they get into the emergency department and then update that anticipated score in real time as the patient's encounter unfolded. We gathered all of the data elements, so what did we use, right? Basically everything is the kitchen sink. Everything that's collected during the ED course from the hospital's EHR. We got patient history, triage information, ESI scores, chief complaint, all the physician orders and when they occurred, lab results as they came back in, vital signs, everything. And we used approximately 3 years worth of prior encounters, so around 200,000 previous encounters, to train this deep learning model to recognize patterns in this clinical data very early on in the ED course that would lead to the eventual true ED disposition. And so then we evaluated this model. We took a portion of the data that we had not shown it and wasn't trained on. We called it a holdout set of about 20,000 unseen encounters. And we ran them through the model to see how it performed minute by minute. And we wanted to measure measure the following aspects of the model. So when we flag an admission or a discharge, and have room on the slide here, how often was it right? Out of all the true admissions, how many of those do we catch early? Like, how many do we catch? And how much earlier can the team start the work, right? So how much lead time does it give them? It doesn't do us much good if we only anticipate the disposition 2 minutes before the DTA, or the decision to admit. So we needed to balance all of these factors and tune this model to perform well. And that was our next goal. We use this evaluation to help us decide where to place the threshold that we use to send this notification to the downstream teams to alert them that an admission or a discharge was going to happen. And the models we built gave us a really big range of thresholds. We could place it anywhere along those lines, giving us a different trade-off between some of those factors I just described. So on the left here, you can see the performance of the admission model. We chose a precision threshold of about 90%, and that captures 53% of those admissions at a very high level of accuracy. And it does so early enough to provide 2.5 hours of lead time per admission to give the teams that time to begin working, and we'll talk about some of the things that they did. This was really just making sure the model worked well enough to go further. On the right, on the discharge side, we were able to select an even higher precision threshold of about 95%. Still, it captures 71% of the discharges, and we broke this down into cohorts just to see, we're not just anticipating that all the 5s are gonna go home, all this, low acuity. It was 4s, 5s, and even some of the complex 3s. And it gave 2 hours of discharge lead time on average. So at the end of this phase, we were excited about the performance of the model, felt that it would be good enough that we could use it more broadly. And the clinical team felt like it was worthwhile going forward, and they agreed to start the clinical validation period, where we sat down with the ED physicians to review cases. So statistician, one of my heroes, George Box, has this saying, all models are wrong, but some are useful, right? And a major consideration in making these models useful in practice is determining when should that notification be delivered to the roles. An early notification just gets ignored and put on the side. You never get back to it. And also what they should do in response to it. But we needed to do this sort of thing prior to integrating directly in the EHR. And so what we did is we developed this tool that we could use to show how the model's score evolved and changed over the course of the ED encounter. And this transparency we showed them when the model would deliver a notification and how the remainder of the encounter unfolded and what their eventual disposition decision was. So we use this tool, which I'll show in just a minute, in the clinical validation sessions with the core team of senior ED physicians to review sets of their most recent patients in the ED. So this was like last week's, shifts, to show them how well the model performed and get their reflections on the following insights. Did the timing feel safe? Was the alert delivered at a clinically reasonable time? Did it match their intuition? This was important because it had to align with those senior ED physicians and make sure it reflected that. And would you be comfortable if the rest of the hospital knew at this point, right? Is it okay to tell everyone? The important part here is that we're not looking for that needle in the haystack. We're not looking for the ones that are going to cause a battle between the ED physician and the hospitalist on that admission consult. We're looking not for the needle in the haystack, but rather to get the hay out of the way and get where there's already built-in alignment so that they can get that patient moving a little bit faster by collaborating on things that they're already agreeing on. And this clinical validation period was important for building this trust with the physicians, even though the focus was to choreograph the team around them. It was not intended to replace their clinical intuition. And it was important that the physicians accepted and agreed with the signals it provided to the rest of the team. And as a part of this, they gave us a lot of important insights, and we implemented those before we ever went live. So I'll show you this. This is our, so here's the tool we use to walk through the patient encounters with the core team. I'll play one of the encounters as an example here in a second. At the top left is that anticipated decision to admit score. This is for the admission model. You'll see it change as the data comes in. In the middle is all of the information that the model uses to build its score. And at the bottom is a timeline of the encounter. You can see the anticipated decision to admit flag and the decision to admit over there on the right, showing when the decision to admit was entered by the ED physician. So we'll walk through a quick case here. You can see this one is a 75-year-old female who came into the emergency department by car, the transport, with a chief complaint of altered mental status. The other two are just for reference that showed how the encounter played out. So in looking at the prior patient history, it shows that she had multiple recent visits to the emergency department, history of COPD, and type 2 diabetes. And at 12:46, the physician ordered a pretty large panel of orders indicating like a suspicion of sepsis based on the panels. Vitals are taken. Vitals show elevated heart rate, low blood pressure, respiratory distress. So the model updated the score to 95, so just below our threshold here. At 1:10 p.m., the CBC comes back and shows I think it's an 18K white count, and that's when the model reached threshold of 92% and indicated an anticipated decision to admit. It was about a little more than 2 hours later for the workup to be completed and the patient ready to go. But you know, this gave the teams like a little more than 2 hours of heads up time on this very obvious admission. And so this was just one example. We've got a few more, but I think this shows it well. All right, so another part of this process was in timing the alert, like when do you deliver it? So we identified 3 key milestones in the ED course that provided the best opportunity for surfacing the model signal of anticipated disposition. So we measured how this would translate to what percentage of the patients we were able to act on at each point in time. So at the beginning on the left, 100% of the patients when they arrive, you don't know their disposition. So after triage data is collected, we found that the model was able to flag 44% of the patients as anticipated discharges and 6% as anticipated admissions. Our hospital admits around 20%, discharge around 80%. So we're catching, a good percentage of the admissions right off the bat. But this was too early, right? So this is way too early to start doing anything other than maybe routing patients to a split flow fast track. And that wasn't the focus of what they needed help with most. So we wanted to wait till a little bit later to the next milestone after first contact with the physician. So at this point in the encounter, after the first provider scene, they have really fast, first physician time. Now the model assigns 52% of the incoming patients to anticipated decision to discharge and 9% to anticipated admission. And this is an activation point that's internal to the ED. It's still too early to involve the hospitals. The orders have just been placed. They're not ready yet. But the activation at this point can be used to accelerate the internal items that can help complete that work, the workup. So about 30 minutes later was the next point, right? And this is when CBCs come back, CMP, high sensitivity troponin, and we see that this has like a small number of patients that it increases on. But importantly, these initial reads give enough for the hospitalist to begin working with on the admission. And we found that this was the appropriate time to bring them into the conversation about the patient at this point, right? So the workup's been accelerated. We can start talking with the hospitalist and they can begin the consult on the admission. So combined admission and discharge, we're able to act really confidently early on about 61% of the patients that walk through the door. At the end of this phase, we were sure that the model was safe, effective. We found some useful timings to activate the downstream workflows. Now the next step was dealing with the EHR and getting it in there. So now the design principle was simple. It was to be as simple as possible. We wanted to use familiar theming with their existing build, able to integrate into each role's trackboard. You can just like pull this into any workflow that was available. It had to be super simple because if if any alert requires a training session to understand, you're already losing, right? It's like you've done too much. So we chose a little blue A to show anticipated admissions, and a little green D to show anticipated discharges. And each one of them has this timer that counts up after the alert was delivered. It's sort of an optional factor that we can do at the build. So as far as introducing the change operationally, we set very conservative thresholds, so we weren't alerting on a lot of the admissions or discharges at first, so they became familiar with it and got used to the types of patients it would alert on. And as the teams became more familiar with the signal, we gradually adjusted it to achieve the capture of as many admissions or discharges as we could. So what changed operationally? How did they make use of that lead time? So on the anticipated admissions, this fed into a prioritization for imaging and labs, just kind of get those going, accelerate the work up. Start doing isolation screening on the ones that you know are going to be admitted, respiratory panels, MRSA swabs, those sorts of things, anything that would affect bed placement when the workup is done. Start medication review with the pharmacy. These are all things that could be done like really early on, like when at that first alert notification time. Then at the second one is when you start initiating internal medicine and emergency medicine communication when they have something to work with. And then they could also start history and physical on the admitted patients. So it cuts down that time. It would cut down that time between the decision to admit and the eventual admit order from the hospitalist. For anticipated discharges, imaging and labs is always a theme. And then also early discharge education, leaning in more on the ones that are more at risk for a revisit, starting that provisional PCP follow-up and planning, care management for outpatient coordination. Those were all the things that we considered for the discharge. So what changed, right? So in our partner hospital, before our introduction, they were already in the top 10% nationally for operational flow metrics in the emergency department. So there wasn't a lot of juice to squeeze out there, and we were a little apprehensive about our ability to move their internal metrics. So they're already operating extremely efficiently. But with these changes within the ED, we were able to reduce their door-to-decision time by nearly 20%, which we found to be impactful for them. So what we learned from all this, right? So there was a lot of, there are a lot of things that we learned along the way. But the key takeaways were that AI works best when it follows clinical judgment. Don't try to interfere with it. Don't try to get in the way. Coordinate the teams around the clinical intuition. Timing delivery mattered just as much as model accuracy. People fixate on how accurate their models are, but they don't really focus as much on when to tell somebody so that they can act. And EHR native, zero-click integration, non-negotiable, it should be table stakes. And iteration and adaptation, which we did a lot of along this way of delivering this, are signs of maturity and not of failure, right? You've got to forge it in reality, and that's all part of the goal. So ED physicians were already right, often very early. And the value came from turning that insight or that intuition into a shared, consistent, and shareable signal, right? The question became, like, how long was it before the rest of the hospital knew, right? And what could change if they knew earlier? And by transforming this intuition into something that could be shared earlier, we turned into this like well-calibrated EHR native signal. The teams could act in parallel. They could start consults sooner, communicating earlier, and ultimately supporting better patient flow without asking the clinicians to really do anything more. So that's the story of us bringing this to life at our partner hospital. Happy to open it up to any questions. We've taken this model and the process I've just described and made it generally available in a product we call Choreo ED. And if you'd like to see if this platform could support patient flow initiatives in your hospital, feel free to come by and find us at the booth. We'd love to talk to you about what our validation process looks like to see if it can deliver value for you. Any questions?